Hello, welcome back to the channel. In this video, I am going to discuss Cambridge International AS Physics Paper 2, which is May 2024, Paper 22. Let us get started. First question, number 1A. The list below shows some SI quantities. Underline the quantity that is not an SI-based quantity. Now remember, in your syllabus, you have altogether 6 base quantities to memorize. One is current, second is length, third is time, fourth is amount of the substance, fifth is the electric current, and six is the temperature. So you have to make sure that you memorize all these 6 base quantities. Now, which is not an SI base unit? Definitely the charge is not an SI base unit. So you have to underline the charge. B, a square solar panel with sides of length 1,300 millimeter is shown in Fig 1.1. Light is incident normally means 90 degrees to the surface of the solar panel. First part, the power of the light incident on the solar panel is 750 watt. Calculate the intensity of the light. Now, this is something to do with the wave that you have learned in the topic of wave. Intensity is defined as power per unit surface area. Now, about the surface area, since the area is not being given, you have to keep on seeking for some clue given in the question. They told you this is a square solar panel. So you need to know how to find the area of the square, which is length times length. Now, power is given as 750 over, remember, intensity. Look at the unit of intensity. It has to be watt per meter square. The length that they gave us is in millimeter. So you have to convert that millimeter to meter. Now I'm going to convert that millimeter. 1,300 milli is 10 to the power negative 3, one of the prefixes, times 1,300 milli as well. And I got 444 watt per meter square. So 444 is the final answer. The second part, the percentage uncertainty in the incident power is plus minus 3%. The uncertainty in the length of each side is plus minus 5 millimeter. Calculate the percentage uncertainty in the intensity of the light. In order for you to calculate the uncertainty, first of all, you have to look back at the equation that you use. I use I equals to P over length times length. This is related to multiplication, related to division. So how are you going to find the percentage uncertainty? When it is about multiplication, when the equation involves multiplication, involve power factor, involve division, involve, to the power of 2, that is called power factor, you have to add their fractional uncertainty. Once you have added the fractional uncertainty, you just take the fractional uncertainty times 100% to find your percentage uncertainty. Let us see how I'll do it. So I'm going to find the delta I over I first. That is the fractional uncertainty of intensity equals delta P over P plus delta length over length plus delta length over length. Now, since I added all my fractional uncertainty, to find percentage uncertainty, you just times 100%. So the whole thing here, you just times 100%. There you go. So this is called delta I over I times 100% is called the percentage uncertainty of the intensity. So you don't have to resolve that. What about power? Power is given as 3%. That is very good of them. But the uncertainty in the length is not being given in percentage. That is why you have to do it 5 millimeter over 1,300 millimeter plus 5 millimeter over 1,300 millimeter times with 100%. So, right? Some of the students ask, do I need to change to convert that millimeter to meter first for the uncertainty of the length? I would say don't have to waste your time because fractional uncertainty has no unit. Yeah, just ignore the unit, whatever unit. Right, so therefore I got 3.8% here. This is 3.8%. The next one, the useful power output of the solar panel is 160 watt. Calculate the percentage efficiency of the solar panel. Now, efficiency, since the power is given, I'm going to use the useful output power divided by input power times 100%. So the output power is given as 160 watt. Input power is 750. Just times with the 100%, and this gives you your 1 mark. So 21.3%, which is quite low. 21.3% is the answer. Now, the fourth part, another square solar panel is placed so that the light of the same intensity is incident normally on it. The new panel has shorter sides, right? Shorter sides than the original panel. The new panel has the same power output as the original panel. State and explain whether the efficiency of the new panel is greater than, lesser than, or the same as the efficiency of the original panel. Now, first of all, I have to use the equation to do this. I need to use my equation of intensity. I'm going to write down equation here, and then I'm going to do my explanation later. So intensity is equal to input intensity is equal to the input power over length times length. Now, intensity is constant. How do I know? Because they have already mentioned it. The same intensity is incident. Right, the output power is the same, but they didn't mention what about the input power, right? So the output power is 160 watt, but the input power is not 750 because the intensity is constant. Now, intensity is constant. I put I constant. You could see that length square, length times length is equal to length square, is directly proportional to the power input. Since the length, the shorter side, remember the shorter sides than the original panel, length decreases. When the length decreases, the input power will have to decrease. Based on efficiency is equal to output power, which is constant, over input power, and times with 100%. You could see that input power and efficiency, they are inversely proportional to each other. I would write that down. Efficiency is inversely proportional to the input power. Since the input power is decreasing, efficiency would have to increase. That's the answer. And I'm going to write that down right now. Now, I said that I state first. I said efficiency is higher as compared to original panel. Now, okay, use the equation to compare. Length square is directly proportional to input power. Okay, I just put length square here because I didn't explain the symbol. So this is length square. Since intensity is constant. Length decreases, input power decreases. And, okay, efficiency, I'll write it here. Efficiency is inversely, I can write efficiency is inversely input. This is input. Inversely proportional to input power as output power is constant. Therefore, lower input power, higher efficiency. So that's the explanation. Second question, a skydiver jumps from an aircraft at time t equal to 0 and falls vertically downwards. The variation with t of her velocity v is shown in Fig 2.1. A part 1, using Fig 2.1, state the terminal velocity of the skydiver. Now, what is terminal velocity? Bear in mind, terminal velocity means the maximum velocity that could be achieved by, in this case, skydiver. So I'm going to put this as this one. Okay, just to read off the value from the graph on your y-axis. Keep my ruler. And the value here is 35, 6, 7, 8, 39. So the answer is 39 meter per second. That is the terminal velocity of the skydiver. Now, the second part, by drawing a suitable line, which is actually tangent, on Fig 2.1, determine the acceleration of skydiver at time t equal to 9 seconds. Now, why do we need to draw that line? First of all, when you look at this graph is about speed against time graph, speed time graph. How do we find acceleration from the speed time graph? It is actually the gradient of graph. But the equation of the gradient, which is y2 minus y1 over x2 minus x1 that you usually use, is valid for straight line only and not valid to curve. This is a curved graph and eventually horizontal, right? So that is why in order for you to use the equation of the gradient, which is y2 minus y1 divided by x2 minus x1, you need to draw the tangent at that given time. So this is a tangent that I drew here. And once a tangent is a line, a straight line that passes through the point stated. So I need to pass through the point at 0.9 seconds. That is why, okay, a straight line that passes through that point. So to find the acceleration is the gradient of the tangent. The purple line represents the tangent. It's actually the gradient of the tangent. So I will just say it out here. Gradient is equal to acceleration. Gradient of line, I better explain it. Gradient of line is equal to acceleration. So now gradient is, okay, I get my two numbers here. I need to have the two coordinates, y2 minus y1, 45 minus 25. 45 minus 25 divided by 18 minus 0. And I got 1.1 meter per second square. So I just want you to bear in mind the range given by the mark scheme. Acceleration is within 0.9 meter per second square to maximum of 1.1 meter per second square. I got the maximum value. So luckily it is equal to 1.1. Now, B, the mass of the skydiver and her equipment is 68 kilograms. The upthrust on the skydiver is negligible. After reaching terminal velocity, the skydiver opens her parachute at time t1. A total drag force of 1,800 Newton acts on the skydiver. Determine the magnitude as well as the direction of the acceleration of a skydiver at t1. Now, to determine the acceleration of the skydiver, because initially when the skydiver is falling, this skydiver reaches her terminal velocity. And once the terminal velocity is reached at 39 meters per second, she suddenly opens her parachute. Due to the large surface area, don't you think your drag force will increase, right? So that drag force is 1,800 acting on the skydiver. So I am going to draw the whole thing here so that you can see. This is a parachute together with the skydiver going down. Right, so you have to identify, in order for you to determine the acceleration, I'm definitely going to use this equation, F equals ma. But this F has to be the resultant force. There is a weight, right? Okay, there's a weight of the skydiver and her equipment, which is 68 times 9.81. That's the weight of the skydiver. So I'm going to calculate that first. 68 times 9.81, that gives you 667 Newton. And at the same time, there's a drag force that is acting. So drag force is here. Drag force is a force that opposing the motion of a skydiver. FD, I just put it as 1,800. Therefore, the resultant force will be 1800. Okay, or if you want to look at the direction of the skydiver, which is going downwards because skydiver is going downwards, I put the downward force as positive. Upward force because it is a drag force, the force that opposing the motion of the skydiver, so I put it as negative. Therefore, I take 667 minus 1800 because I'm considering downwards as positive. Mass of the skydiver and her equipment is 68, and you need to find the A. Therefore, the A is equal to negative 16.7 meter per second squared. Now, since they asked me to just determine the magnitude, I'll just say 16.7. And the direction, because downwards is considered as positive, I get a negative value, meaning to say that the direction is upwards. Now, see, the parachute is fully open at T2. At a later time, T3, the skydiver reaches a constant velocity of 5.7 meter per second. Describe and explain the variation with time of the magnitude of the acceleration between T2 as well as T3. I will say that due to the decreasing speed, which is true because initial terminal velocity is 39 meter per second. And now another new terminal velocity is reached due to the opening of the parachute, which is 5.7. The speed is actually decreasing. Since the speed decreases, the drag force acting on the not parachutist, yeah, is the skydiver. I'll change this. Skydiver will also decrease. Therefore, when the drag force decreases, the resultant force will decrease and the acceleration will also decrease. And at one point, when drag force is equal to the weight of the skydiver, resultant force is equal to 0. And therefore, the acceleration is also equal to 0. Now, the second part, calculate the change in momentum of the skydiver between time T1 as well as T3. So sky change in momentum, this is a symbol of momentum, it is mv minus mu. So since the velocity, both velocities are going downwards, both velocities will take positive value. So the mass of a skydiver is 68, v is 5.7, minus u is 39. Now, 5.7 minus 39 times 68. I got negative 23, I round it off, 2300 Newton second. That negative represents the change. So when I fill in the blank, I just put 2300 Newton second. Now, question number 3, lightning occurs when charge builds up in the atmosphere, creating a potential difference between the ground and the atmosphere. During a lightning strike, there is an average current of 3.3 times 10 to the power 4 ampere for a time of 2.6 times 10 to the power -5 second. Calculate the charge transfer during the lightning strike. So I will write down whatever information is given, current is given, time is given. So to find the charge, I just calculate. That is how I remember stuff. Right, 3.3 times 10 to the power 4 times 2.6 times 10 to the power -5, and the answer should be 0.858 coulomb. Remember, that's the unit of charge. 858, or you can put a 0.86. It doesn't matter. B, the potential difference between the ground and the atmosphere is 3 times 10 to the power 7 volt. Calculate the average power in gigawatt transfer during the lightning strike. So, since the voltage is given, PD is given, I'm going to find my power as IV. I is 3.3 times 10 to the power 4. V is 3 times 10 to the power 7. The answer is 9.9 times 10 to the power 11 watt But hey, remember, the question wants us to change it to giga. Giga is 10 to the power of 9. So you have to move to the front, right? Okay, because this is, you have to move it to the, okay, hold on, this is 10 to the power of 11. So giga is 10 to the power of 9 to move it to the front or to move it to the back. Because when you move the decimal points to the front, you are adding to the power of that to the in the multiple of 10. So when you are shifting this decimal point to the front, you are adding to that power. So I want it to decrease the power to the power of 9. So I put this as 10, decreases 1 to the back, I minus 1, 10, 9. So I get 990 times 10 to the power of 9 watt, or 990 gigawatt. So the answer is 990 gigawatt. C, a lightning rod is attached to a tall building to conduct charge safety to the ground, which is very true because that is our one of the safety, that precaution that we take, to protect the tall building from being struck by the lightning. So the lightning rod is modeled as a uniform cylindrical copper cable of total length 95 meter that runs from the ground to the top of a building as shown in fig 3.1. Now the first part, the resistance of the lightning rod is 9.6 ohm. Resistivity of the copper is 1.7 times 10 to the power negative 8 ohm meter. Determine the radius of the lightning rod. So why do they keep on asking to find the radius? Now, since the resistance and resistivity are given, form an equation first. How about that? R is equal to rho L over A. Do you still remember? Right? I find my A first because A can be related to the radius. R is equal to 9.6. Resistivity is 1.7 times 10 to the power negative 8. And remember the length given is 95. I find the surface area of the rod first. A is equal to 1.7 times 10 to the power negative 8 times 95 divided by 9.6. A is equal to 1.68 times 10 to the power negative 7 meters squared. Now, I want you to remember one thing. When this is about the wire, this is about the rod, you have to imagine, okay, you have to assume that the surface area is a circular. Now, do you still remember? Recall a little bit of math here. Area of the circle is pi r squared. Now I can relate to radius. 1.68 times 10 to the power negative 7 is equal to pi r squared. R is equal to 1.68 times 10 to the power negative 7 divided by pi and square root the whole thing here. And the answer that I got was 2.31 times 10 to the power negative 4. 2.31 times 10 to the power negative 4 meter is the answer. Second part, the radius of the copper lightning rod is double. Okay, with no change to its length. State the effect on the resistance. When I was asked to state the effect, you have to look at the equation first. Equal to pi r squared. Now, r is equal to 2r, double what? So a is equal to pi this r squared. So okay, what happened here is that now the new A is 4R squared. That is why the resistance R is equal to rho L over A. Everything else is constant. It is just that R is inversely proportional to A. But since A increased by a factor of 4, R will have to decrease by a factor of 4. That is why I say R decreases by a factor of 4 to be exact. D, a section of the lightning rod of length 0.12 meter is removed for testing. A tensile stress of 1.9 times 10 to the power 6 Pascal is applied. I put here stress. As shown in fig 3.2, section of the rod obeys Hooke's law. Young modulus of the copper is 1.3 times 10 to the power 11 Pascal. Calculate the extension of the section. I am going to use this as extension. Young modulus is equal to FL over AX because stress over strain. Now F over A, stress is being given. Young modulus is 1.3 times 10 to the power 11. Stress is given as 1.9 times 10 to the power of 6. And then length is, length here is given as 0.12. So I put 0.12 divided by x. Make x as a subject. X is equal to 1.9 times 10 to the power 6 times 0.12 divide 1.3 times 10 to the power 11. Extension is equal to 1.75 times 10 to the power negative 6 meter. 1.75 times 10 to the power negative 6 meter is the answer. We move on to question number 4. Number 4, a pinball machine uses a spring to launch a small metal ball of mass 4.5 times 10 to the power negative 2 kilogram up a ramp. The spring is compressed by 8 times 10 to the power negative 2 meter and held equilibrium. Equilibrium means not moving, as shown in fig 4.1. Now the ram is at an angle of 15 degrees to the horizontal. A, the spring obeys Hooke's law again, and a spring has a spring constant of 29 Newton per meter. Calculate the elastic potential energy of the compressed spring here. I have spring constant, therefore EPE, or elastic potential energy, that I'm going to use to calculate. I'm going to use this equation, half kx squared. K is 29. X is the extension, which is given 8 times 10 to the power negative 2. You square it, and your answer is 0.0928 joules. 3 significant figures, 928 joules. The next one, the spring is released and expands quickly back to its original length. First part, calculate the increase in the gravitational potential energy of the ball when the spring returns to its original length. When the spring is being compressed, right? And then when it is released and it will expand due to the ram, the ball is moving up even higher. Don't you think so? Now, we are supposed to calculate the gravitational potential energy. I am definitely going to use back this diagram. So I am going to take, okay, I'm going to shift my angle here. I want you to see it closely. Okay, I'm going to shift this angle here. I'm going to use only this part of the ramp. And this is 15 degrees. I'm going to redraw that out because hypotenuse is given, which is 8 times 10 to the power negative 2. I'm going to draw it out here. So this is 15. Okay, this is the H that I'm going to calculate. Increase in gravitational potential energy. And this is 15 degrees. This is 8 times 10 to the power negative 2. So I'm going to use opposite sine 15 is equal to h over 8 times 10 to the power negative 2. H is equal to 8 times 10 to the power negative 2 sine 15, which is equal to 0.021 meter. Now increase in the gravitational potential energy, delta GPE, which is equal to mg delta h, or just h. M is given as 4.5 times 10 to the power negative 2, g is 9.81, and h is 0.021. And my answer was 9.14 times 10 to the power negative 3 joules. 9.14 times 10 to the power negative 3 joules is my answer. Now the second part, the ball leaves the spring when the spring reaches its original length. Assume that all the elastic potential energy of the spring is transferred to the ball. Calculate the speed of the ball as it leaves the spring. Now I'm going to use the principle of conservation of energy. I'm going to use the total initial energy is equal to total final energy. Now, total initial energy is due to the elastic potential energy because the spring is being compressed. And final energy, the ball increased in height, remember? So it changed to GPE and it will change to KE because the ball will eventually move and leaves the spring. Now, EPE, I got the answer, which was the first part that you have calculated, which is 0. Okay, I want you to see this, 0.0928. Remember that? So I'm going to use that. This is 0.0928 So this is 0. Okay, this is 0.0928 GPE, gravitational potential energy, which is 9.14 times 10 to the power negative 3, if you remember. 9.14 times 10 to the power of negative 3 plus KE, which is half. M of the ball is 4.5 times 10 to the power of negative 2. And just put V square here. Now, when you work it up, V is actually equal to 1.93 meter per second. So 1.93 is my answer. C, the ball comes to rest on a horizontal trapdoor of negligible mass at a constant D from its pivot. A force F acts vertically downwards at a distance of 2 cm from the pivot, as shown in Fig 4.2. Now, the first part, the trapdoor is in equilibrium when F is equal to 1.7 Newton. So what is equilibrium? That means not moving, or in other words, you can say that anti-clockwise moment is equal to clockwise moment. So which is anti-clockwise and which is clockwise? I will use my pivot to see. Now, force is going downwards. While going downward, it will seek for the pivot. So it has to turn in this direction. This is anti-clockwise. And ball, there's a weight of the ball, which is downwards. While going down, the weight of the ball is going down. It will turn towards the pivot. So it has to turn to the left-hand side, which is in clockwise. So anti-clockwise is 1.7 because the force is given times the perpendicular distance, which is 2 cm. But I'm going to change that 2 cm to meter because look at my final answer. D must be stated in meter, so which is 0.02 meter. Clockwise, which is the weight of the ball? Weight of the ball, weight is equal to mg. Mass of the ball is 4.5 times 10 to the power negative 2. And g is 9.81 times d. Make d as a subject, you will soon get 0.077 meter as the final answer. That's the answer. Now, the third one, the force F decreased from 1.7 Newton and state the direction of the resultant moment about the pivot on the trapdoor. Since the force is decreasing, look at anti-clockwise, it is decreasing. So the anti-clockwise moment is decreasing, so the clockwise moment is larger. So what happens to the resultant moment? It will have to turn in clockwise. Yeah, direction of the resultant moment is in clockwise direction. So that's the answer. Number 5 states Kirchhoff's second law. So do you still remember there are two laws of Kirchhoff's? One is first law, the other one is second law. First law is about conservation of charge. The total charge, right, into the junction must be equal to the total charge coming out from the junction. So same goes to current. So this charge, because current is about the movement of charge, right? What about the second law? So second law, I state in a closed loop. Remember? In a closed loop, the total EMF or electromotive force, right? EMF or equals to total PDs. Remember that? That's Kirchhoff's second law. B, a battery of EMF 9 volt and negligible internal resistance is connected in series with a variable resistor X and a thermistor Y as shown in Fig 5.1. Fig 5.2 shows the relationship between the temperature and the resistance of the thermistor. Now, first, the current in the circuit is 1.1 times 10 to the power negative 2 ampere. Potential difference across Y is 4 volt. Calculate the resistance of X. Could you see that X and Y are connected in series and the potential difference across Y is 4 volt. This is 4 volt. So the remaining potential difference across X will be 5 volt. So I'm going to calculate PD across X is equal to 9 volt minus 4 volt, which is equal to 5 volt. And once I get that, I could calculate the resistance of X. How do I use it? I use Ohm's law. Vx is equal to IRx because X and Y are connected in series, so they share the same current. Vx is equal to 5. I is 1.1 times 10 to the power negative 2. Rx is the one that I have to find. Therefore, Rx is equal to 5 divided by 1.1 times 10 to the power negative 2. The answer is 455 ohm. 455 ohm is my answer. Second part, the temperature of Y is changed to 190 degrees Celsius. Resistance of X remains unchanged. Determine the new potential difference across Y. Now, let's look at the graph here. Because the temperature is changed to 190, which is somewhere here. This is 190. So you have to look at the resistance of Y because Y is the thermistor, so its resistance depends on the temperature. So 55, 10, 20, 15, 20, 25, 25 ohm is the answer that I got from the graph. That is when Y is 190 degrees Celsius, its resistance will be equal to 25 ohm. Now, okay, how do I do this? I need to find the new potential difference across Y, but I also need to find the new current because due to the resistance of Y that is changing, the current will have to change because the total resistance is changing, but the total EMF is not changing, right? So from Ohm's law, V total is equal to I or I total, R total. V total is equal to 9 volt because they didn't mention that they changed the battery. I total is the one that I have to find because the total resistance value has been changed. It is between Rx and Ry because both are connected in series, so you just add out their resistances. So at 190 degrees Celsius, resistance of Y is equal to 25 ohm. So 25 ohm plus 455 ohm. I total is equal to 9 divided by 25 plus 455, and I got 0.0189 ampere. And now I can find my potential difference across Y. Vy is equal to I total because both X and Y share the same current, Ry. Vy current is 0.0189, Ry is 25. And the answer is 0.469, sorry, not ohm, but volt. 469 volt. So 0.469 volt is the answer. Now, third one, resistance of X is increased. Temperature of Y remains at 190 degrees Celsius. By reference to the current in the circuit, state and explain the effect of this change, if any, on the potential difference across Y. So since the resistance of X is increasing, the total resistance, because X and Y are connected in series, so you just add out their resistances, right? The total resistance will also increase. When the total resistance is increasing, because the total power, the total potential difference, I want you to see this. This EMF is not changing, right? It is still the same EMF, right? So when R total, Rx increases, R total, which is equal to Rx plus Ry, will also increase due to the increment of Rx. Now, using Ohm's law, V total is equal to I total and R total. V total is constant because they didn't mention that they changed the battery. I or I total is inversely proportional to R total. R total is increasing, the total current that flows through X and Y will have to decrease. Right? But since the circuit is a series circuit, and I will say that due to right potential difference, because now I want you to see this. When if you do want to use the current to explain, because you need to find the individual potential differences across X and Y, you can also do using potential divider concept. So I am going to use, if you want to use the potential divider concept to explain, which is way easier. So they ask you what happens to the potential difference across Y, right? For potential divider concept, because the current is the same and potential divider is only valid to series circuit. Now, let us see this. Okay, I'm going to write down potential divider Vy over 9. Because they didn't change the EMF of the battery, is equal to Ry over I better put, okay, I don't want to find Vy first because Vy is Ry is not changing. I put Vx over 9 is equal to Rx over Rx plus Ry. Could you see that? Now, the resistance of X is increasing. That makes the potential difference across X would have to increase. But the total potential difference or the EMF is equal to Vx plus Vy. Vx is increasing, but V total, which is 9 volt, is constant. That is why Vy must decrease. This seems to be easier way to explain. Right? So I'm going to write down total resistance. I don't want to use the total resistance. I don't want to use the Ohm's law to explain. I would say that since EMF, okay, 9 volt is constant, current flows through X and Y is constant. V, okay, potential difference is directly proportional to the resistance. V total, total EMF is equal to Vx plus Vy. Rx increases, Vx increases. Okay, hence Vy must decrease. So Vy will have to decrease because the total EMF is constant. Now, the next one, question number 6. Light of single frequency is incident normally on the diffraction grating. An interference pattern of bright and dark fringes forms on a semicircular screen shown in fig 6.1. Light has a wavelength, lambda 520 nanometer. Separation of the lines of the grating, this is lambda, is 3.8 times 10 to the power negative 6 meter. Determine the total number of bright fringes form on the screen. I am going to use this. D sine theta is equal to m lambda. I need to determine this m first, number of orders. How many number of orders has been formed on the screen first? Now, if you want to determine the maximum number of bright fringes that could be formed on the screen, sine theta, okay, must be equal to 1. Yeah, theta must be equal to 90. Sine 90 is equal to 1. D 3.8 times 10 to the power negative 6 is equal to 520. Nano is 10 to the power negative 9 times m. Therefore, m is equal to 3.8 times 10 to the power negative 6 divided by 520 times 10 to the power negative 9. M that I got was 7.31. But m is a number of order, right? So in this case, only valid to diffraction grating when m, okay, you need to round down to the closest whole number. Right? Even though I get the answer as 7.99, you still have to round down to 7 because that 0.99 is too faint to be seen on the screen. Now, to find the total number of bright fringes, you take 7 multiplies by 2. Do you know why I multiplies by 2? Because on the screen, you are going to form, the bright light. After being diffracted, it will form 2 first order, 2 second order, 2 third order, right? So you have double first order, double second order. And plus with the 1. The 1 is called undeviated beam. You have to count that as well. So 14 plus 1, you get 15. So the answer is 15. B, the light is replaced with red light of single frequency. First part state whether the frequency of a red light is greater than, less than, or the same as the frequency of the original light. I have to say this. This is a wavelength of the original light, 520 nanometer. So you need to have a little bit of knowledge about the wavelength of the red light. Wavelength of red light is between 600 nanometer, which is higher wavelength, longer wavelength, to 800 nanometer. Since the wavelength of the red light is longer, that is why the frequency of the red light is smaller. So the frequency of the red light is supposed to be lesser is the answer. So the second part, state and explain the effect of this change on the number of bright fringes formed on the screen. A calculation is not required. I would say that since lambda wavelength is longer, right, more diffraction would be formed. Yeah, so this light will undergo more diffraction. Therefore, the number of the bright fringes is actually lesser because more diffraction means more spread out. More spread out, yeah, most of the bright fringes couldn't be formed on the screen. So that's the answer. I would say, since wavelength is longer, more spreading occurs, right? So hence, number of bright fringes, bright fringes formed on screen is lesser. So that's the answer. Number 7, a particle Q and R are each composed of one quark and one anti-quark. A, state the name of the class group of particles that includes Q and R. I call it as meson. One quark, one anti-quark. B, Q has a charge of negative 1e, where E is the elementary charge. R has a charge of 0. Complete table 7.1 to show a possible second quark in each of Q and R. I would say that since Q has the charge of negative 1e, so strange, first quark is already strange. So the second quark, I will put anti-up. Why? Because anti-up will take negative 2 over 3 E, right? Plus negative 1 over 3 E, you get negative 1 E. What about R? R, no charge, free of charge. So the first quark is anti-up. Second quark will be just up. Up and anti-up, they are opposite of each other. So up is positive 2 over 3e. Anti-up is negative 2 over 3e. So you get 0. So that's the end of our discussion. I hope you gain benefits from it. So thank you very much for watching. Bye.